Welcome back to your information gallery. Today we will see how to build or design a PCB. I'm using KiCad 9.0. How to install. I made a video on LinkedIn, the description. Now let's start our first project. Today I'm building very small circuit to understand design flow. For that we need to go to File, New Project. You can choose your own destination where you want to be. I'm choosing First Project, and I'm giving the file name. LED circuit. Save it to create two files. One is for _PCB for PCB editor and _SCH for schematic editor. We have to double-click schematic file. It'll open blank page. To fill the title, we need to go to File, Page Settings. Issue date. You can mention your current dates. Title LED. Circuit. Company your information gallery. Okay, it's updated. And the next thing, you should place the component. As a small component, I don't save any diagram, so I am just placing the component here. This is the symbol for place the component. Or you can press a letter in the keyboard. It will load all the libraries, including footprint libraries as well. Now for my circuit, I need a terminal. So I'm using terminal with 2 screws. Okay, to rotate the component, just or later in the keyboard. And I want this. First terminal to converse to a mirroring. Okay, now we can press a, or if we click on right-click, there's a place symbol you can see. Here. So we'll open again for play, simple window. Now I need a register. I type R for register. Okay, I will rotate. I'll just keep it here. And right-click. I want one LED. Okay, rotate. And I give one LED. And I want power for ground. The power symbol item. I can press ground. I'll place it. Here, now select. Now if the KiCad didn't give this or 1D1 like that, we need to annotate. That annotation automatically assigns unique reference designator like R1 or 2D1, like that component's inverse schematic. Each component must have a unique ID before generating the net list or PCB layout. Here we can annotate it. Sorry, here, annotate schematic. If you annotate, it will assign the numbers. As I am using KiCad 9.0, it already assigned, so no need to do that. Now we need to assign values. For that, we need to double-click the component. Here, value. I'm giving 350 ohms. Okay, now we need to connect the circuit through wire for that shot. Cookies W letter on the keyboard, or we can click this button, or if you go to this terminal it will give. That's simple. To connect, just click draw and click it. Complete that connection again. Click. Click you need to connect to terminal and click. Click. We connected the circuits. Now we need to do ERC. It takes for electrical errors in your schematic like unconnected pins, conflicting power nets, or missing connection. It helps catch design mistakes early before PCB layout. For this, you have to click this symbol electrical rules checker. Run ERC, it give an error input power pin not delivered by any output power pins. This is why. Because we didn't give any source power source here. It's things like it doesn't have any source. So we need to add power flag. Power flag is a special symbol in KiCad schematic library that tells the ERC. This net really does have a power source. Don't flag it as unpowered. For that again, we need to go to place a power symbol shortcut is P. Write power flag. Description. Also here you can see special symbol for telling ERC where power connection comes from. So I will rotate it. I will just add it here. Go to select, and I will just adjust this name. And this name as well. Okay, again, we'll do ERC. Run ERC now, 0 errors and 0 warnings. Now we need to add footprint to this circuit. Each schematic symbol, like resistor, LED, needs a physical footprint that matches how it will be placed on the PCB. For example, any register for SMD, or register a dip aid for ICS like that. Food frames define the part size, spacing, and mounting style used in PCB layout. For assigning footprint, we have to click this symbol Assign Footprints. These are the components we have in schematic. This is LED, so we need to select LED in the library. LED through hole TH. In this level, whatever available, it will show here. I will. If you don't know how to choose based on your requirement, you can choose. Otherwise, you can just check randomly how it will be you can. Footprint looks like, and you can use the 3D view also. This is not what I want, so I'll just close it and it'll go to diameter 8. Select footprint. This is how the footprint looks, and in 3D model how it looks. We'll see. Yeah, this is what I want. So we need to select LED. We need to double-click it. It will assign that port print. This for terminal, we need to go terminal blocks. These are different types of terminal. I'm collecting Phoenix, and first one is 4. Wait, this is 4. 2 terminal, 2 screws. So we can use the footprint. And 3D view. How it looks like. And I had selected here, so double-click it. It will assign for register. We need to go to Register. Through Hole. Here we need to check Register. The length is kind of big, so I'll choose this one. In 3D view. Perfect. You can choose your according to the specifications. Now, assign there, we can click on Apply. Save Schematic and continue. It's saved. Okay. Now we assign footprint. Now we have to route. For that we need to open PCB editor. Switch to PC Predator symbol we need to click. It will open a blank page. From Schematic to we need to update PCB. Further, we need to click this symbol Update PC from Schematic shortcut is F8. Update PCB. Then close. Then you can click and place it. Now I need to rearrange this. Before routing, select drag, and you can also rotate. Click drag. Click drag. Okay, before outing, we need to draw the outline. For that, we'll use Edge Cuts layer. Is the PCB outline layer defines the physical shape of and size of your board. You draw it using lines or rectangles on Edge Cuts layer. The PCB manufacturer uses this layer to cut the final board shape. Further in the layers, we need to select Edge, Cut Selected. Now Rectangle, we need to click this Draw A. Rectangle. Droid based on your specifications. Click, we draw the rectangle, and in the head cut layer only we can add circles. So that we can have a screw in the board. Escape, and we'll just yeah. Yes, we added holes. We can also rearrange it. Select and drag. Our head cut is ready before routing. We have to switch back to P.cu. Is the bottom copper layer. It's where copper traces are drawn on the P on the bottom side of the PCB. It's used in double-sided boards for routing signals and power lines on both sides. So we selected B.cu. Now we can draw. Draw the traces. The shortcut is X, and this route signal track symbol we need to select. And we can start the trace. and click Android. And don't race for grounds. For that, we need to do filled, though. Filled zones, usually for ground or power or large copper areas that fill section of the board. You draw a filled zone and assign it to a net-like ground. It reduces noise, improves grounding, and saves copper during etching process. After drawing, you must press B to refill the zone. This tells KiCad to fill the area around existing tracks and pads. Without pressing B, it only shows the boundary, not the actual copper area. So far, dirt. We need to click on Filled Zone. Shortcut key is Ctrl-Shift-Z, and you need toggle in the circuit sheet. Click Select Ground. Then OK. Then start drawing rectangle. And you need to connect. Further, you can zoom in and connect it. Now you can see, we just draw the boundary, but it is not filled. Okay, so for that one you need to select here and press B. Yes, now it's all connected to ground. Ground. You can see this. For routing, is the drawing copper layer. Tracers on PCB. This is the copper traces. Component pins, according to schematic nets. It replaces wire with copper pass. Good routing ensures signal integrity and manufacturability. And we can add text logos here for friends. Silkscreen. It shows text, component outlines, and labels printed on the top of the PCB. It helps during assembly and debugging by identifying parts and orientation to select UH. Front sales screen F. Silkscreen, you need to select now. We are in front, we can add text. I will add let. Circuit. We can rotate it using arc. I'll paste it here. And we can add logos. That is, place footprints. You could search logo. You'll give EST logo and KiCad logo screen. I will add this kit design with KiCad. And we can also add other logo CE logo. Also we can add. See logo still screen. Okay. We'll add one more logo. Waste Electrical and Electronic Equipment Directive. So we'll add this one as well. If I want to add backside, what we can do is to select text. You are in. We're going to make it board. Okay. This is front. Well, but I want it backside, so select right-click in the name. Change side or cliff. So now it will come in backside of the PCB. Okay, that's it. And we'll see 3D view of this circuit diagram. PCB, so 3D viewer Alt-3, it will work. We can click on this symbol as well. This is the final circuit. I have terminator terminal and register and LED. This is the logos and my circuit name. And this is whole first cruise. In the back side, disconnected ground we can see, and this is the path we routed. Trace it, and this is the name we given and flipped. So that's all for today. Thank you for watching. If any suggestions, comment box will be open. You can give me suggestions. Thank you.